presentation. Today's Cloud Native at Scale. It's going to be a little bit of a showcase, which is a little different for us. So we're going to have three presenters presenting a wide variety of products here. And as we do with all things kind of native at scale here. As usual, I think with a new tradition, I will start with a really bad pun here. So they say, don't start a pillow fight with death unless you can handle the repercussions. So anyway. And with that, I'm going to pass it on to our first presenter, Colin Sullivan. Colin's at Synadia. He has a background in messaging, and he's going to be presenting on NATS, which is a kind of what I call a global messaging product. So on to Colin.
All right, thanks, Jim. Let me go ahead and share. Oh, I apologize. This is not letting me share my screen.
I think it's me, actually, is the problem here. Maybe. Let's see here. All panelists. You should be able to share it now, no? Maybe.
Oh, you know what? I just upgraded my OS, and I need to enable this really quick. Just 1 second.
Exciting. Don't you love that? I think Marco, you probably remember Marco was working on a demo, and we had some problems with that.
Okay.
If you want, we could maybe kick it over to Leigh, but we'll give you just a minute to go ahead and
Sure. I'm trying to go. I think I got it. You know what? It's not letting me share my screen here. So if you want to kick it off to someone else, that would be great, and then I can see if I can resolve this.
Sure. I hope I'm not the problem. Leigh, do you want to kick it off? Sorry to put you on the spot there, but if you could kick it off, that would be great.
Hey, yeah, for sure. I can do that. Just let me make sure to add this other cluster. And in my kube context, and it should be good to go.
See here.
Yeah, I can give a little introduction for Leigh while he's working on that. Leigh is at Weaveworks, and he's a developer experience engineer and principal there, and he's going to be presenting the Flux, which is the product for syncing Kubernetes with automated updates and other such needs for the pods.
Yeah, Flux is dope. Definitely going to be getting into some good details with Flux here. Sorry, just cleaning up this kube config so I can add my new demo context for you friends, because I'm going to be doing a live demo today. Like getting into some actual cluster operations as well, and make sure that this is coming up.
So I think I've resolved it if you do want more time for setup, Leigh.
Yeah, actually, if you're ready to talk, Colin, then we can.
Yeah, let me.
We can do that. Yep.
I'll see if this works here. Hey.
Yeah, I can see.
Right.
There we go.
All right. So I'm Colin Sullivan. I'm product manager of NATS. Long time. It's been a long time in distributed computing, 20 some odd years, a lot of time with fintech, aviation verticals, and long time at TIBCO as well. And I've been a maintainer on the NATS project for about 6 years now, and then product manager for 4. So what is NATS? NATS is a 10-year-old production-proven cloud-native distributed communication system. NATS was built for developers and operators that just want to do their work. They just want to worry about getting their job done and not worrying about messaging. So to that end, simplicity is something really important to us, along with performance, security, and high availability. NATS was built from the ground up to support modern architectures. Its first use case was the underpinnings of Cloud Foundry. We support multiple qualities of service and making sure messages can arrive, support for multiple communication patterns, and I'll go into this in a little bit, and over 40 client languages and frameworks. We are part of CNCF, as you know, and we're in the streaming and messaging category. So NATS was created by Derek Collis, and Derek's been solving really hard problems in distributed computing for a long time now. He's built a really good team around NATS with people with a lot of messaging experience. But even more important, we have a very, very engaged user community. So we have over 1,000 contributors, over 100 with more than 10 commits. So what's a number of our contributors like to just keep contributing. That's a good sign. Over 90 public repositories, and across all those repositories, we have over 20,000 GitHub stars. It's kind of a vanity metric, but we do have over 150 million Docker pulls and over 3,000 Slack members. So we've really started growing. The trajectory of NATS seems to really start to be taking off. And we have about 5 releases a year of the NATS server. Recently, we've had a lot more. We've had a couple big releases, and I'll go into more detail in a minute on what's included there. Now, who's using NATS? We have users of all sizes, all verticals. NATS is really an enabling technology, allowing these enterprises, small companies, or even pet projects to communicate across the cloud or on-premise or to the edge. So to that end, you won't really see one vertical here. You'll see a really healthy mix. So in high-level features of NATS, one of the things that we need to that we like to talk about is location transparency. So once you connect to NATS, it doesn't matter where you are anywhere. As long as you're connected to your NATS deployment, publishers and subscribers can be anywhere. They can move. You don't care where something lives. And then this also allows for decoupled data producers and consumers. So a producer doesn't necessarily know or care, have to know or care about where a consumer is. In fact, even if you're storing data in Jetstream, which is our persistence, the consumer may not even exist yet. Being one technology, NATS is highly observable. So we have lots of monitoring, system events, and you can view an entire NATS deployment just by connecting to one server. We do provide delivery guarantees and allow you to replay streams of data. There's resiliency through self-healing. At any point in time, you can have a NATS deployment and add a server to it or add multiple servers to it. And the servers chatter, they let each other know about the new servers, meaning that you can grow a deployment at runtime with no configuration changes. And even better yet, what happens are the servers actually let clients know, hey, I've got 2 new servers, right? So these clients can actually fail over to servers that didn't even exist when the clients initially connected. We do support layer 7 load balancing. So when you have an application connect to NATS and you subscribe, you say, I'm interested in this particular set of data, you can add yourself to a group that then NATS will load balance between this group. And at any point in time, you can add to this group or remove from this group. And we have ways to gracefully have applications remove themselves from these groups. Again, this is at runtime, no configuration changes whatsoever. NATS is very flexible, runs in any cloud, runs on VM, can run on bare metal, run edge to endpoints, and we're highly secure. I could probably talk for an hour about NAT security, but at a very high level, we support MTLS, username or password. We actually prefer something called N-keys, which is our own security scheme, and it uses ED 25519 key signing and verification to verify applications are who they say they are. And along with this, we have true multi-tenancy with secure data sharing. So with true multi-tenancy, when an application connects, it connects and belongs to what we call an account. And applications within account have their own set of security settings, but let's say everything's wide open, they can just freely communicate. They can freely communicate on any subject, register interest in any subject. And you can have another account, same set of subjects, those messages will not pass between those account boundaries, meaning that you have a multi-tenant system, and at any time, I can say, all right, account A gets access to this set of data from account B, and then data sharing can occur. And this allows you to build very easily a SaaS solution atop NATS. As I mentioned, we have over 40 client languages. If there's any client languages that don't exist, we're happy to build them and adopt them. General use cases of NATS. So why do people use NATS? Most common is just general distributed communications. So microservices, that was NATS' first use case. Event streaming and data streaming, which is observability, analytics, and then command and control. Along with that, we're seeing a lot of uptake with IoT and edge, where we have a NATS deployment in the cloud, it's extended out to the edge, and I'll go into more detail in a minute on that. But there you have telemetry, sensor data, and again, command and control. And as companies are making their journey, and companies still are making their journey to the cloud, we also help augment or replace legacy messaging. So you might have an older legacy messaging product, and we can bridge into NATS for the cloud, or a lot of times it's just a replacement. We get asked a lot, where can I run NATS? So the NATS server is a standalone executable, and there's no external dependencies. Everything is all in one server. We can run in Kubernetes, we can run standalone in Docker, bare metal, VMs, we can run on edge devices, and the NATS server can also run on a very resource constrained device, Raspberry Pi 2. It can run anywhere Golang can compile. On a Raspberry Pi 2, we were able to get about 2 million messages a second through without persistence, just in memory. So if NATS performs really well, and I notice, if I pump 1 million messages through server on my machine, I use about 10 meg of RSS. So we're very, very efficient at what we do on the machines. We get about 18 million messages a second with one server, one data stream, and 80 million messages a second per server with multiple data streams. This is in memory, not persistence. Persistence, you're going to be limited to how fast you can store things to disk. But in memory, we can do this. And while most users don't necessarily need this, this translates into scalability. So if I can perform this well with a couple of servers, that means I don't have to worry about scaling for a long time as you grow. So let's talk about a really, really simple deployment. So simple deployment is a single NAT server and a couple of clients. One might be producing data, one might be consuming data. And this is like what I would run on my laptop. If you're running in Kubernetes, you can get away with just a single NAT server because Kubernetes will restart. You'll have a little bit of downtime, but it's an option. Little bit more complicated, but not really, is a clustered deployment. So a clustered deployment is full mesh one hop. So you have a client connecting to a NAT server, another client connecting to another NAT server in the cluster. It doesn't matter which server they connect to. From the client's perspective, I'm just connected to NATS. This cluster can change. You can lose servers. Clients will fail over to other servers automatically. You don't have to configure anything in your application. And this provides you high availability. With Jetstream, clusters can be 3 nodes or 5 nodes. With core NATS, there's really no limit. We've seen 10, 12 node clusters. I think there was one user that tried to do clusters in the hundreds. We ended up helping them with a different architecture, but NAT servers can cluster. Now, a cluster is great for a single region, but when you want to go across regions, you can set up clusters of clusters with what we call gateway connections. So these clusters of clusters use a spline-based technology with special connections that we have that are optimized for a WAN. So there's less traffic, less chatter going across that. And there's no limit to the number of clusters in a supercluster. So you can get 30 or 40 across the globe and create a global network of NATs. Now that you are running these clusters, we've allow you to create what we call leaf nodes. So here's a cluster that might be running in the cloud. And then you can have a leaf node, and this could be running on an edge device. This could be running on a cable box, on a router, or in a car. And what happens is any data between these clients will stay on this leaf node except for data that's supposed to go to the cloud. This solves a lot of problems in edge computing and allows you to build just massive, massive NATS deployments and ultimately have millions of client connections, millions of clients operating, yet still have access anywhere in your NATS deployment. This gives us what we call the intelligent adaptive edge architecture. So if you squint, all of this looks the same in terms of a NATS deployment, where you might have a central region. So let's take connected car. You've got a central, which is headquarters. You've got a number of shared services or streams, which it could be location services, weather, metrics, security, and then a remote entity, which would be a vehicle, and endpoints are various systems on the vehicle. If you go to manufacturing, industry 4, you've got headquarters, and then factories would be your remotes. You might even have another layer of servers close to line machinery. So this same architecture can be applied to many, many different verticals. We have a very, very simple API. Here is all you need in Go to publish a message. You connect to NATS, you just give it an address. It could be a DNS address, it could be an IP, whatever you need. And then after you connect, you simply publish a message, and that's it. Here's a application in Java that subscribes. I connect, I create what's called a subscription. So I'm going to say, so this Go published to a subject called metrics. Here I'm subscribing to metrics. So I'm going to receive any information published from that Go application. And again, if you look, the only topology you need is this NAT server. So you can have a very, very complex topology in the background behind the scenes, and your applications remain extremely simple. And the other important thing is this application can move anywhere in your deployment so long as security is set up. Along with NATS, we have Jetstream, and Jetstream is a subsystem in the NAT server. You flip it on with a configuration option, and Jetstream supports at least once delivery, exactly once within a window. So that's if I need to guarantee a message gets there. Most of the time, we recommend that users start with designing for no persistence, and then only when they need to add persistence. But Jetstream does allow you to store messages, and then you can replay by timer sequence. It's embedded in the NAT server. We have wildcard support, which lets you filter on different subjects. It's NATS 2.0 security aware. So you can have a Jetstream within an account. You can set up a server to say, all right, well, I'm going to allocate 2 terabytes for Jetstream, but this particular account only gets 100 gig. And you can partition it out that way. We support data at rest encryption. You can cleanse specific messages. This is mainly for GDPR. We have horizontal scalability, and then you persist data in streams, but you read data via consumer, and consumers can look very, very different for the same stream, which allows you to consume data for your application in whatever works best for you. And then we have built-in mirroring and sourcing. So if you have 2 different clusters in 2 different parts of the world, you can just tell the NATS servers to, hey, mirror this stream, this persisted stream from cluster A to cluster B, and it will automatically do that. There's no external components. And then also sourcing. So I can say, all right, I want to create a stream and source, 10,000 other streams into this one stream that then I might want to perform data analytics on. We've had a couple really big releases. For those of you that know NATS and been following, in NATS 2.2 and 2.3, we had Jetstream Go GA. We have simplified account management, where if you're using the ED25519, the JWT style account credentials with NATS, you can upload them to the servers, and the servers automatically take care of sharing these. We have CIDR block and time of day account restrictions. So you can say users, this particular user can only connect from these IP addresses, or it can only connect between 8 and 5. Default user permissions, where if you connect and there aren't permissions set up for a user, we allow you to assign defaults. A big one is WebSockets. So much bigger than we thought it'd be, because a lot of times when people are deploying NATS or really any software that communicates, you're fighting with security teams to get through firewalls. WebSockets makes this very, very easy. We do have native MQTT 3.1.1 support. We have had a lot of users in the IoT space reach out and ask for this edge computing and reaching out to devices. So we've added MQTT 3.1.1. You can take any existing 3.1.1 MQTT deployment, replace it with a NATS server, and it will automatically bridge that data back into the cloud. And then subject mapping and traffic shaping. So you can map subjects. You can say, all right, if I want to change what this interest looks like. So let's say I've got a subject on metrics and I wanted to change that to telemetry. I can do that. There's also traffic shaping, where I can take a set of subjects and assign a percentage of data to go through. And what this is really good for are canary deployments. I might have a couple services. I'm going to onboard a new service. So what I'm going to do is map that to another subject for the new service and give it like 1% of the data, just to sanity check before then I onboard it.
Hey, Colin, we got a few minutes here and we have some questions in the chat. So the 20 minutes goes by fast.
Oh, I've already gone through 20? Okay.
Almost, yeah.
Oh, wow.
Give you a few more minutes there. And we have some questions. I don't know if, looks like some of them have been answered. They're in the chat there.
All right.
I can't tell which ones, but if you want
to, and
maybe...
one in the Q&A as well. So
okay.
All right. So I think I need to stop sharing here to answer the questions. There we go. Let's see what the questions are here. Apologies for running over. In the benchmark example,
not at all. It's fascinating.
In the benchmark examples given, it was just IO limiting factor or memory CPU. So with the performance examples, that was actually it's a theoretical limit, because with that level of throughput, you're not going to be able to have IO keep up. So NATS, when you're doing performance tests, is almost always IO bound. The caveat being, when you're using Jetstream and you're persisting data to disk, you're going to be going as fast as your disk can spin, or hopefully you're using SSDs. So Jetstream, you're limited by how fast your disk is, and then otherwise you'll be IO bound.
And I think we had one more question that wasn't answered here. Can you configure retention for the stored messages, or is it only in quotes data volume driven?
You can configure retention. So you can say, I want to store X number of messages. I want to store messages for this period of time. And then those are the two other ones. So, or number of bytes. So, and what you can do is you can create a stream with a short retention policy. and then mirror that stream into a stream with, let's say less expensive storage that then has extremely long retention. So you can use your high-speed SSDs or even memory only with short retention mirrored into a stream that's elsewhere that has longer retention policies.
Wish I had this 25 years ago.
Well, we've all we've all learned from our experiences. It's as Derek says, it's not rocket science. It's just a lot of scars.
Yeah, exactly.
All right.
Any more questions for Colin here?
Yeah, so we got about another minute or two. Did we answer all the questions there? Looks like I think we covered most of them. Leigh, thanks for sharing that link to GitHub there, answering that question. I think we've covered everything. Maybe Colin, you could finish off with this: is what's the main takeaway that you would like our audience to come away with from your presentation, would you say?
Pretty simple. If you want to democratize access to your applications, to your streams and services across any type of deployment, NATS is a tool you should look at.
Awesome. And if people want to get involved in the project, what would you recommend for them to maybe get started?
Yeah, I would recommend joining our Slack organization. We do have a number of issues that we've identified as like good first issues, good low-hanging fruit. And then, yeah, get on Slack. The maintainers are almost always on Slack. We have maintainers all over the world. So, and just ask how you can help. And we're very appreciative of the help.
Awesome. Well, thanks so much, Colin. Really, really appreciate you joining us on vacation.
Absolutely.
What everybody knows, he decided. So we're going to let Colin leave a little bit early. And so, Colin, we have this recorded. We'll share this with you, and we'll share your presentation with everybody on this call. And yeah, so everyone, if you have a question, please put it in the Q&A. It's a little easier to manage it that way. That would be great. And yeah, Jim, so I'll turn it over to you, and maybe just another quick little introduction for Leigh, and we'll take it from there.
Thank you all. Thank you so much.
Thanks, Colin.
Thanks, Colin.
Have a great vacation.
Great presentation. Yeah, thank you. And so next we're going to move on with Leigh Capili with Flux. Again, it's a automation for Kubernetes, kind of above and beyond what you think normal automation for Kubernetes would be. Again, he's development experience engineer at Weaveworks. So I'll pass it over to you, Leigh.
Thanks, Jim. Yeah, awesome presentation about NATS. I learned quite a few things about the supercluster things. And certainly these multi-cluster topologies are becoming much more prevalent as Kubernetes is being widely adopted in our ecosystem. And I'm really excited to see all of our open projects across the CNCF. There were a couple of questions about like whether NATS was open source, and it's important to note that what we're showcasing are the incubation projects across the CNCF, a hand kind of picked selection of a few of those projects. And all CNCF projects are going to be at their very core governed at the kind of like highest standards of open source and community standards. And so these are projects that of openly governed software that is maintained by communities of people from multiple companies, and it's the kind of thing that you would want to build your business on top of. Flux is in the same kind of generation of tooling that NATS comes from, where we govern the project very intentionally so that it is supported by maintainers from multiple companies, that everyone gets a fair say in the project. So come and get involved. I'm going to talk a little bit about Flux today. Set up my screen share here. I got slides and a terminal because I like to talk a little bit, just give you some context, and then we're going to do a demo. So I'm going to blast through some of these slides. Flux is about GitOps, right? The Flux community has been one of the biggest players in this movement to define what the continuous delivery practices that actually formally make up what GitOps is, which it's a real thing, and it's something that's beyond continuous delivery. It's a subset of it. But GitOps is, that's just my intro. You know, I do a bunch of stuff. I work on this thing called Ignite. It's a Firecracker, micro VM, Docker UX thing. You should go check it out. I contribute to Kubernetes. I like helping people, and the Weaveworks folks are so amazing to work with. Why GitOps, right? So the Flux community wants to define GitOps practices really clearly for folks, right? So we want to describe systems declaratively, keep the configuration of those descriptions in source control, because that's where we like to collaborate on these things, right? And then we want to use software agents wherever they're running, if it's inside of a cluster, if it's running in some CD workflow, if it's firing off of a bunch of events reliably, but we want to continuously reconcile and ensure the correctness of our declared configurations that we version, so that we can monitor and alert for things like drift and be very confident about the state of the systems that we're operating, right? So this is what GitOps is. And it's not necessarily about using Git for source control, although it's a very popular thing, right? At GitOps days, we had people talking about using sheet ops, like storing configuration in spreadsheets, Google Sheets, you know. If you want to use SVN, Perforce, whatever you want, right? You can still do GitOps, but it's the core of this is that we want to declaratively store our config and source control and constantly reconcile to make sure that's correct in our environment. Right? And so you get some benefits from this, right? Git is a great place to be collaborating on infra. We have these platforms on top of Git, like GitHub and GitLab, and devs love this, right? Because we can leave comments. We can see when things happen. We can go look at the history of a particular file. And so when we're talking about that with infrastructure, then all of the things, the investments that we make in our Git collaboration platforms, the way that we work with each other, the access control, the auditing, the security benefits, the ability to understand what drift was intended or what change was intended versus what we're seeing now in terms of drift in the environment. You have these really clear boundaries and places to work with each other. Right? So this is more than just a technical solution, this is a social solution, right? When we talk about DevOps and continuous delivery, we can also think of GitOps in that same solution space, right? And so Flux is great for GitOps because, as we were talking about with the CNCF governance, we have built a community that is building the software tool set, the toolkit of solutions that people need to assemble the way that we want to work with each other. Right? And because we're in this CNCF space with all these cloud native tools, we get to bring in all of our friends, right? We can bring in Prometheus for our metrics interfaces. We can bring in Helm, right? And actually integrate it with it natively. We can use Customize, right? And we're gonna do all of the cloud native interfaces so that you can build a really cohesive system that is very fun and sensible to operate, right? This is a slide from last year, June. You can see that CNCF had a bunch of technologies on their radar, and they did really highly recommend that Flux is something that you should be adopting. Cool stuff. The community is really strong, 40,000 contributions across lots of repos, and these stats are actually a little bit out of date. We've got a bunch of maintainers from different companies. Go star our repo and contribute, you know, get some commits in there if you like. This is an awesome place to be, and I love the people that I work with. Lots of users as well. Flux is deployed in production everywhere. We've got Flux 2 now, which is not yet generally available, but already serving production workloads. If you ask anybody who's involved with the Flux project, they would say you'd want to be using Flux version 2, right? That's the Flux that we want people to be adopting. It is the evolution of continuous delivery and Git on Kubernetes. Right? Flux is built with a bunch of very extensible interfaces. We have a rich feature set, right? If you are using Flux, you get declarative Helm, right? Helm is usually something that you imperatively operate with. There are a couple of projects that try to fix that. And what we have in Flux is something called Helm Controller that lets you make a custom resource that describes your Helm release. And anytime you change that resource, if it needs to happen, it'll do an upgrade for you. So you no longer have to make these imperative declarations to say, hey, I got to move my Helm release because I updated my Helm chart. It just knows now, right? Because you're doing things declaratively with your configs in Git. You can do health checks and dependent ordering between the different components, the way that you partition your workloads and delegate them to people. You can compose multiple repositories together. This gives you good multi-tenancy because you can use the Kubernetes native API to split things up with ownership of RBAC. You can manage multiple clusters. You can apply things from one cluster to another cluster using Flux if you've set up the credentials properly. Right? You can do different kinds of tagging policies. You can work off of multiple branches. I mean, this is just a continuous delivery goldmine, because if you've ever adopted a tool that enforces a workflow on you, you find that it might not fit into the way that your developers work together. But with Flux, we don't have that problem because we let you build the platform and encode the policies that you need to flexibly create the kinds of pipelines that are going to work for you. Lastly, it's important to note that Flux is just way more observable than it used to be. This used to be a massive problem with Flux 1, but now we've got Prometheus metrics on everything. You've got K-status compliant statuses inside of each custom resource. You can alert on that. You can make like all sorts of things. You can extend it with your own webhooks using the notification controller with alerts and receivers. It's just really good stuff, so go check it out. And lastly, just before I get into the demo, I just want to really call out some main personas. We're always thinking about these people when we are contributing to Flux, right? We've got the cluster operators who need to wrangle and manage complexity in these really complex environments, right? You've got a bunch of Kubernetes clusters everywhere. What version is that? Is that thing in the state that I actually wanted it to be, right? It's hugely important for cluster operations. And the platform engineers who actually then interact with all of the components necessary to make that cluster usable for dev teams, right? People who are managing service meshes, who are setting up and building abstractions on top of alerting, who are trying to release a standard Helm chart. The platform engineers, we're going to be really interested in using Flux to help developers release software in a consistent way that's understandable to cluster ops. And the developers are also going to want to know, hey, is my code out there? What version, right? And so you're really bringing this kind of DevOps culture shift to continuous delivery with some formal APIs and interfaces in the GitOps style. So hopefully that's making sense cohesively. And if you are looking to get started, there really is a lot of directions you can go here. But we've got some good tutorials on YouTube already. If you're looking for more of this type of content, I've done a lot of these videos along with a bunch of other amazing speakers. Check out our playlist. These slides are also going to be posted to the meetup. So now I've got a repo for this, right? Because we're doing GitOps. If you want to do exactly what I'm doing, you can fork this repository. You can spin up a K3D cluster, install the Flux command line tool, and you're going to be good to go, right? There's not a lot of other ways to do cluster ops where you can say those things, but because of Flux, the consistency of the tooling, the principles of GitOps, that kind of thing is possible, right? So yeah, let's do a K3D cluster create. And I'm going to do a Falco demo for scale. So that'll be my kube config. Make that cluster. And what else should we do here? This is going to be kind of hard to add to my lens config. And then we'll just do a Flux Bootstrap. So here I'm in the Falco Flux repository. This is, the repo that I was just showing you on the slide there. Stealthybox, Falco Flux. And then what I'm going to do is a command called Flux Bootstrap. So we're going to bootstrap to GitHub. Just gonna make sure to keep track of your questions here. Flux Bootstrap GitHub. So I'm telling the Flux command line tool that I want a GitHub repository to be hooked up to my cluster. Right now, I'm going to start with one repo, but we can always just branch out to multiple repos, multiple Helm repositories, all that kind of stuff from the control of that single repo, right? And I can port multiple clusters to the same repository. So there's a lot of flexibility here. You can do whatever you want. I'm the owner here. That's my GitHub user. The repo is this name. I'm going to be using the main branch. It's a personal repo, not an organization. That's just a GitHub client thing. And then I'm going to be using my token for auth here inside the cluster instead of generating an SSH deploy key. So the science of Flux Bootstrap is to help you wrangle the complexity of configuring your Git platform, generating keys, opening up access, and then also configuring your Kubernetes cluster to then sync up to those things with those credentials. Flux Bootstrap can wrangle that with API access as long as it has credentials to your cluster and to your Git platform at the same time. Right? So pretty nifty tool there. So you can see here, right, I've started the command and it's connecting to GitHub. It's going to make sure that there's a repo that's already there. If it wasn't there, it would have created it. But since I have the repo up, it's using it. So it's an idempotent workflow that's safe for your existing clusters. Make sure that the manifests are up to date. If it needs to do a push, it'll do that, And yeah, then it reconciles those components that are inside the repo into the cluster to get everything stood up so that we can get to a synchronized state from day zero of this cluster, right? It's a brand new K3D cluster with no components installed in it, aside from the stuff that comes from the Rancher toolset. And we're just gonna install Flux and get it hooked up to the repo. And then all of the declarations in the repository are then going to be reconciled into the cluster to get it to the state that I want. So I'm not running a shell script that's running kubectl apply on different folders in a particular order. I'm not going into the cluster and then copying a secret from somewhere so that other things can come up, right? I'm just telling it, hey, look at my Git repo, make the stuff happen. Right. And there are even things that you can do with secrets management with our integrations with SOPs, sealed secrets. If you want to hook up some private keys from your cloud KMS system to bootstrap specific secrets that are encrypted in your repo, that's the kind of thing that's possible with Flux. So a lot of really good management stories here. We'll go ahead. Let's examine a little bit some of the declarations that are well, actually, let me just make sure to clip. I want to, let's see, I don't know if that's going to be valid. Just got to update my kube config in Lens here.
Hey, Leigh, you have about 5 minutes.
Excellent. Thank you very much.
You're welcome.
Duplicated key mapping.
I think we have some questions too, so we'll wait for you to finish there.
Okay, cool. I always hate doing this because my kube config's a little bit invalid. That's cool. We don't need Lens. I'll just use kubectl. Great. So some of the declarations that are in here, just want to show you some high-level things. Is if we go into the Flux system directory, then this is where Flux gets bootstrapped, right? So there's this Git repo definition and this customization definition, right? So this clones the repo into the cluster and makes it available as a source. And then I can use that source and apply a folder from it. I can do that every 10 minutes. I got options to like prune things. If things get removed, I can enable or disable validation. That's the sort of separation of concerns I can get. You see that these are on different intervals, right? And so, okay, well, this is just a custom resource that gets applied to the cluster. I can make the cluster clone repos and apply folders. Really cool, right? I can hook up different service accounts and stuff to this. So if we were to look in like the Falco system namespace, you can see I make a namespace here, right? Here's a couple of Helm release definitions. And then in the kubeless folder, there are 2 sinks here as well. So there's one that actually installs kubeless, and it has a health check to make sure that kubeless gets installed correctly. So kubeless is a functions as a service platform, right? I don't have to know much about the complexity of this to know that what we are installing as a cluster operator, is the kubeless platform. And then I can see that there's a bunch of workloads here, and that the workloads for the functions that actually deploy as a custom resource, it depends on the kubeless installation, right? And so all of this is declarative and can be applied in a single step to the cluster. And then as you're applying things to the cluster, assuming that everything bootstraps and comes up healthy, then you can get the status of those things specifically. So I can do like a Flux get sources get in all namespaces, right? And now I can see that I have cloned 2 separate repositories. There's a monitoring repo and a Flux system repo, which is my Bootstrap directory. And I have these references that are cloned to the cluster, right? So I know exactly what version of code I'm looking at. I can open that in the GitHub user interface if I want to browse around or link somebody. In addition to the sources that I have cloned, I can look at the customizations in the cluster. So I can see, oh, okay, well, my main Bootstrap is done, but the monitoring system is still being installed, and kubeless is still being installed and isn't healthy yet. Right, so I don't have to go looking around for pods to try and figure out the status of things. I know that the kubeless installation is not done yet because the health check isn't yet passing. Similarly, I can see that the functions that depend on my kubeless installation are not installed yet because that dependency is not ready. Right, so Flux hasn't even tried to install the workloads yet because it's not at that stage of deployment yet. We're not at that point in the graph. And so this is the power that you get. You can see how reproducible it's like. You've got a single repo that declares the entire state. I say, hey, make the cluster look like this, and you can get there. And that puts me in a really comfortable place from a security perspective, from a disaster recovery perspective, to say, hey, I can rip this cluster down. I can make a new one and get to the same place that I need to be. That's the power of GitOps. Really, really cool stuff. Go try out the demo yourself and see everything is rolled out now. Our functions are deployed. It's good stuff, right? Really, really fun. As far as questions and that kind of thing, happy to get to it. But that is the kind of main story there. You know, get involved with the meetup, check out the playlist, download Flux for yourself, install it on your cluster so you can get to managing your workloads in a much more comprehensible and collaborative way, right? And if you think that I should do something differently with my cluster ops, you can PR my repo, right? That's GitOps. But yeah, Flux is sick, totally. Craig had a couple of questions. He says, what's the current status of Flux 2 with respect to Argo? Flux and Argo are kind of sister projects in the GitOps space, but fairly separate, right? So we did do some collaboration to produce a component called the GitOps engine, and the Argo team did start building some of their components on top of GitOps engine. We ended up building Flux 2. So we were originally going to refactor Flux 1 onto GitOps engine, but we ended up going a different technical direction. And yeah, both of the projects are super high quality. They come from some different places. Just small differences in governance and style and that kind of thing. You should go check out both. And it's worth noting that Flux components and Argo components do interoperate together. So if you want to use Argo workflows and Argo rollouts, which are great progressive delivery and like DAG workflow runner tools with Flux, that's a good platform. And we know that people do that and are successful. Similarly, if you want to use Flagger, but with Argo CD, that's totally a thing, right? So yeah, the projects don't directly integrate, but they interoperate well since we're in the cloud native space. And there's governance and high quality software in both projects. You should go try them. I think that was the main question there.
Maybe real quick in the chat. We're definitely, I love your passion, Leigh. Definitely have to, I feel like you could talk for hours on this, which is fantastic. And
I certainly can and have. Thank you, Josh. This is a huge compliment. Yeah, it's just so exciting to be here with everyone at the meetup. And I'm always, available to chat more as well. So totally, we should get to that next speaker since we have so many amazing projects in this ecosystem.
Absolutely. Thank you.
Great, that was awesome. Yeah, next we're going to have Bartek Plotka. Bartek is a principal engineer at Red Hat, mainly with observability, and he's going to be talking about the Thanos project, a cost-efficient observability pardon me, product that integrates on Prometheus 2.0 and is particularly efficient with the storage of metrics and all the like. So I will hand it over to you, Bartek.
Thank you. I hope everyone has still some energy. Can you hear me well?
Yeah, we can hear you.
Perfect. Let's go. Let me share my screen.
Bartek, we have lots of energy.
Great. It's your morning, so I bet you have. All right. Cool. Hi. Can you see my screen?
Yes. Yeah, we can see it. Looks good.
Looking great.
Amazing. So welcome everyone. It was amazing to learn about projects that were introduced previously. I never used any of those, and I'm super keen on learning from projects in the same kind of organization like CNCF. We have really similar problems. What I heard, similar challenges, similar patterns, how we deal with those challenges. So it's definitely a lot of we can learn from each other. So it was great to hear about those, and please keep going with those kind of showcases. So today I would love to kind of introduce you to Thanos and kind of tell a little bit what it is, and maybe something around future interesting things that are happening in this space. So I think Jim introduced me well. I'm principal software engineer at Red Hat. I'm kind of responsible for architecture around observability space in OpenShift particularly. And I'm all in open source for a very, very long time. I'm maintaining lots of projects, mostly in Go, mostly around observability, but also distributed systems. And I'm writing book with Leigh around this space as well. So getting to the observability first space, I'm pretty sure everyone here is very familiar with the Observability Pillars. It was introduced very long time ago, I think initially by Peter Bergen, and at least that was where I first seen that. And we can categorize the data that we can observe from our software into three categories, right? We can have tracing, which is kind of request-driven information that takes the context from many services on the request hopes and kind of present you this nice tree of what was happening, what were the latency of this one particular request with additional attributes. We have logging, which is kind of basic, just low level human readable, usually bytes that are sent for every event. So it's kind of event based, not really bound to any request. And at the end, we have metrics, which are aggregations, right? So they're kind of statistics, they are numbers. And I would like to highlight that that's not the end of the story. We have kind of more signals coming up in this space. One example is continuous profiling. So this is something I'm super, kind of impressed about as well. We kind of maintain one project around that. It's called Conprof, worth to check it out. Super useful when you want to just check your performance over time. So kind of observability. And who knows, there might be more, right? So at the end, I will be talking about metrics because this is where Thanos project is all about. And let's start first with some use cases, right? And I think the primary feature of metric is that they are cheap, right? They are actually the cheapest and the fastest, which means they are closest to real-time observations you can make in order to debug your application, maybe monitor health using standard paradigms from many SRE DevOps strategies around the world, including methods like RED and use, which are stating for rate, errors, durations, and utilizations, duration errors, or something like that. So any of those kind of high-level statistics that tells you quickly if your system is healthy or not. You can alert on those behaviors. You can notify humans. You can notify also computers, trigger some auto-healing procedures based on that, because those things are accurate and fast. And last but not the least, you can analyze that, especially if you have capabilities to store this data for a long-term duration you can have an enormous kind of retrospective knowledge about your application, what was happening. Plus, you can measure those long-term signals like your SLO, how your SLOs were compared to the previous stage, how it is now. Are you violating SLO? Finally, you can have error budget, alerting, and lots of those kind of more complex strategies. Sometimes billing, some can KPIs. Really, many you can get from just metrics, right? So probably, when you think about metrics and the kind of in the cloud native space, one project that comes to our mind is Prometheus. And in fact, I personally was using Prometheus in my previous job for a long time. We're early adopters. At some point, I became maintainer of Prometheus, and I really love that, right? Because first, community is great. Secondly, it's so simple project, but so powerful. You can have everything in one package, in one instance, in one binary. There is no replication, but at many cases, you don't need that. And this is like unnecessary complexity that you can ignore. And you have flexible PromQL. It is kind of based on shoulder of giants, right? It's standing on the shoulder of giants, like Google Borgmon is really similar solution. So it's actually super powerful as well in terms of performance. I've seen 200 million, 100 million huge Prometheus instances, but typically it's healthy to keep it under 10 million series for the ingestion part. Because at the end, it's just one instance of it, usually running for your cluster, right? So at the end, it allows you to alert, query, store this data and collect, we call it scrape. So pull metrics from the application, which is like another story why it's amazing, because you can simply, the client side of the application is extremely simple. You need to expose one HTTP page, and you leave out of this, discovery problems, rate limiting, any configuration, buffering, persistence to the central model, for example, like to the some Prometheus, some collector. It's no longer a responsibility of applications. So I love it. But at the end, it is some way of getting those metrics in. So why I'm talking about Prometheus? Well, we started with Prometheus in my previous job, and at the end, as many others, we went into some problems, right? And really the problem is that at some point you have more clusters, you have more than 10 million series. You want to have high availability. So you want to make sure that if you upgrade your Prometheus, there is some other collector that will take this data and that you can use this architecture and actually use it transparently, right? And last but not the least, we want to make sure that the data is not only on local disk, but we can kind of save it somewhere else, backup it to the cloud ideally, and have some long-term characteristics I was talking about. So this is where we kind of invented with Fabian Reinhardt, co-creator. Together, he was on CoreOS, I was at Improbable, the startup before. And we decided to kind of try different idea and kind of try to have distributed Prometheus. We both were Prometheus maintainers, so we knew the internals. We knew that we could leverage lots of things. We literally imported Prometheus code to make it happen. But at the end, we aimed to solve high availability and horizontally scalable scalability of the metric setup. We wanted to solve global view. So we wanted to make sure you can aggregate your data from multiple clusters, multiple of those collectors. You can have long-term storage, downsampling, which is part of the long-term storage kind of mechanisms to make it cheaper to store this data and faster to actually query. And multi-tenancy at the end, because we are going into this managed services, direction. Every company kind of do this nowadays. So, this is why Thanos was started 4 years ago almost. We are part of the incubation 2 years ago. 1 year ago, I think we were incubated. We were fully open source from the start. I really love, Leigh, your amazing introduction to the CNCF space, why we really love the open governance, why project joins the cloud native computing foundation, because they want to have some trust that this will be open license forever, right? That's why we had kind of have this think in our mind as well when we're building Thanos, right? To make sure it's open and kind of trusted. That's why CNCF was the perfect spot for us. And at the end, yeah, we have many users. I asked recently, how large your setup is. People are running with more than 400 million, sometimes 300 million series for just single setup. So it's kind of crazy, scalability in this sense. We have lots of adopters. Those are just who were willing to actually show themselves. But we have kind of grateful to have like large community. But let's talk about the Thanos, how we kind of did that from the scalability perspective, architecture, how to use it, right? So we, as I mentioned, we are Prometheus maintainers, and we started from Prometheus, right? And when you look on Prometheus, understanding the underlying structure, we can see that there is some query engine, some scraping engine, compactor, rule alert engine. There was a receiver recently kind of part, and kind of many more. So what we did with Thanos, we essentially get each of those portions of things into separate microservice, right? And query engine now can be deployed as a Thanos querier, which is just one Golang binary that you can run multiple commands with, like Thanos query, for example. You can, scrape engine. We can use Prometheus for that, and add just sidecar for kind of unification of API. A rule and alert engine becomes Thanos ruler. So just some global rule evaluator, compactor, global compactor, and at the end we allow backing up data into object storage. So there has to be some kind of gateway that allows you to fetch this data in our format, right? And that's not the end. We wanted to have like very flexible toolkit that you can actually configure the deployment as you really want. You can mix those components together. So we added even receiver kind of component, which allows you to use remote write kind of streaming purpose. So you can kind of you have two ways of adding data to Thanos system. You either pull it directly from some collectors like Prometheus, and that also uploads some data in a lazy fashion to your object storage, or you can have totally separate egress traffic only Prometheus or some agent that streams metric directly to the Thanos system, and you have all of the data centrally. So this is kind of how we evolve as well. But there is certain concept I would love to share here, which allowed us to evolve in an easy and simple fashion, so everyone is not lost after those changes, right? And one thing that allowed us to do this is gRPC framework and API that we developed. We call it Store API. It is very simple, but at the end, what is really kind of amazing here is that all of those components which store some data allows you to give this those series, those metrics to some global query evaluation Thanos querier are having the same API. So from perspective of the Thanos querier, those are exactly just transparent implementations. They don't care if it's a store gateway or receiver or Prometheus. They give you exactly the same API, which allows many integrations. Like we have integration with OpenTSDB, with, I don't know, you can have local kind of implementation of store API. So it's very powerful. And we do actually the same to aggregate other stuff like scrape targets, alerts, around monitoring, but primarily kind of functionality of Thanos is to make sure you have those metric storage and querying capabilities around that. So one thing I want to mention that we are going to improve in a short future, and something that came to our mind as an evolution step as well, is that at this point, to allow global querying, you need to perform PromQL evaluation. So this, amazing query where you have, you can sum, aggregate, maximums, whatever, average over time, predictions even, and do those evaluations while getting data from all of the nodes, all of the leaves, right? And in order to do that, you need to have a global query evaluation on this Thanos querier. You can actually have a tree of it, so you can kind of federate that in hierarchical way. But at the end, you need to fetch all this data to this global place. What is really amazing and what we are working on is kind of this MapReduce concept that is allowed by our architecture. And this is very similar to Monarch system at Google. Like they do also similar stuff around MapReduce. They essentially reduce the query to the well, they kind of schedule the queries in a way that you can have partial evaluations on the leaf nodes, and then partial results are getting aggregated on the global level. So you reduce a lot of traffic, network traffic, and you can essentially parallelize things much easier. And PromQL is not very trivial in order to do it accurately and without losing precision. But this is something we are working on right now, because especially with this Thanos architecture, we are going to leverage this kind of leaf and tree composition very nicely. So this is what I wanted to show as something nice that we are working on. I actually wanted to demo this and show some cool, I don't know, hacky version of it, but I just returned from vacations and I didn't have a chance to finish it. But I have some quick demo for you anyway, without query pushdown yet. That's how we call this feature. But there is something new in this because I did lots of Thanos demos and my team colleagues, I wanted to have something fresh. So in this demo, instead of showing you some terminal where we specify each, I don't know, Kubernetes service and Kubernetes pods with Thanos kind of architecture, we kind of wanted to show you some cool module. It's called, I don't know, end-to-end. This is something what we did with the Cortex project as well, and it allows you to quickly run some processes in the Docker containers, but from the Golang programmatically, and it's kind of pretty cool. Really, it's kind of outside of Thanos itself. It's rather something that maybe other projects written in Golang or kind of microservices would be super keen to see. So let me quickly show you that. I hope you see my Golang IDE. Can you confirm that maybe?
Looks good. We can see it.
Perfect. So this is kind of the Golang test. So you can see that we have just Golang code with Golang tests. I call it query pushdown because I started working on it, but it's just deployment of Thanos. So what's special about that is that you can just orchestrate everything from Golang programmatically. So what I do, I just create the data because we want to query something. I don't want to wait weeks to have 2 weeks of data. So I create literally Prometheus TSDB blocks. So this is exactly what Prometheus will construct when you scrape and collect some data. I just create 3 sets of those. Together, there are like 2 weeks of worth of data. There are some diagrams to show that. So first of all, we will start Minion, which is our object storage emulator. Actually, it's proper object storage on the disk. So it's pretty cool. We copy the data we generated into 2 buckets. And there are like week worth of data. We call one of set of data Europe and replica 0. We call another one US to simulate, I don't know, 2 clusters, for example. Then we have store gateways. So as I mentioned, there has to be something that kind of give you this data in required Thanos format. So we create that against those buckets. So we create one bucket configuration, again in Golang, and just start Thanos store. And if I show you kind of underlying code, this is like orchestrating Docker container, nothing more. Some image, some Thanos Flux, Thanos configuration, some port mapping, and really just it. And some readiness prop as well. So we start to store one for bucket 1, second for bucket 2. And then let's go for 3 another nodes, let's say, right, in the system. So in this case, we would love to create 3 Prometheuses. Why not? On a single machine. Hopefully it will not explode. And we create kind of, again, two sets of data, so two clusters. So we have one in Europe, let's say cluster, and we create kind of two containers for that set of data in a HA group. So we simulate kind of some way of having a high availability for collection, Prometheus 1, Prometheus HA0, HA1, EU1, replica 0, EU1, replica 1. And then we have US1, replica 0, so kind of another Prometheus, let's say, from different Prometheus, only one replica. So we create those Prometheuses. As I mentioned, we need to have some sidecar. So we create 3 sidecars next to the Prometheuses. You can see I reference everything in code. That's why this module might be amazing for someone who loves Go like me. And then we copy some data in as well. So we make it fun. So we copy one set of data to Prometheus HA0, then only 5, so I don't know, half of the blocks we copy to the another replica to make sure it doesn't have a full picture. It only has some, let's imagine it has some issues. And then second set is going to another Prometheus. And then there is some Prometheus configuration, which is super basic. I don't script anything for now for this test. I only set external labels, which allows me to specify some kind of identification of the node itself. I start everything, I start menu, I start all my things, and then I add up this Thanos query, this global evaluation, which has some UI, has some PromQL, exactly the same APIs as Prometheus, and allows you to have a global view finally on all of this data, right? So I start that up, I point to all my store APIs. You can see I point to all gRPC, and I start it, and then I open some browser tabs. So let's see if that works. The power of it is that it is usually super fast. And it's starting up. So yeah, let's go for like 1 minute more. I know we are over time, but 1 minute more around how we can actually see this global view happening. So
Bartek, this is great. So we'll give you a few, yeah, go ahead and finish what you're doing, no problem.
We'll go. So let's go. So here, what we have, now I need to double check to the configuration what we have here, but we have cluster US. So we have kind of Prometheus, the second Prometheus. Let's make it sexy dark mode. And we have some, example data that is like generated metric, but imagine this is like, I don't know, summary of your CPUs or things like that. So we have kind of 100 of those metrics. We just summarize all of them. And you can see we only see 1 week of this data, and this is for US cluster, let's say. If we go to another tab, this is replica, second replica. We have here EU data, and we can see it's EU because its configuration is specified as EU, as a replica 1. Kind of thing to note is, can I have this back? No. So let's again try quickly copy that in. I want to show you that we don't have enough data. Like this is our partial copy. So you see you have lots of gaps. And then at the end, we hopefully should see the Prometheus first one. Let's see. It has EU replica 0, yes. And sorry for changing colors all the time. You can see that there is 1 week of this data. But what's bad about that imagine I want to summarize this metric across all those 3 things. So not only I need to go to each of those tabs and manually try to get the value on particular moment, like, I don't know, 10 and something gigs, and then kind of sum with my another tab, another Prometheus, and then I'm even totally confused if I'm kind of having 2 replicas and one of them is kind of flaky, but overall I have the data. Right? This is where Thanos comes handy. We kind of have this really the same similar UI with maybe additional fields, but what we have here, if we go to the store before I explain this this graph, you can see we have all our stores, all our nodes visible. We have 3 sidecars for each of those Prometheuses. We have all those external labels. We have even time kind of time for which we have this data available. It doesn't work great on just fresh Prometheus that didn't scrape anything yet. So that's why it's kind of funky. And we have 2 store gateways indicating that we have some long-term storage from bucket data, also with some labels that can identify some of the data from there. And what it gives us is gives us global view, right? So finally, we can see that we have both EU, both US, and also replica 1. But now again, this is the high availability here is not transparent to the user. You can see I need to kind of still have this broken view. So what is amazing is that by default, you deduplicate in Thanos. And in this case, it actually masks you the gaps because it has the data from both. There is some penalty algorithm which is proven and like thanks to the community, almost bulletproof nowadays. And we can deduplicate this data very accurately. And at the end, what's actually amazing by all of this, we don't need to manually, do the summarization. We can have all of this in one place. So this is the high-level view. Let's get back to the presentation. So just to finish up, how to get started with Thanos, I would really recommend going to Katacoda tutorials. This is like interactive tutorials with Kubernetes, with Docker, and around different Thanos deployments. We really, with community, working really hard to make sure this is kind of high quality tutorials you can just walk through in your browser. We also organize mentorship, and it's not only, by the way, for students, but also for like, full-time job engineers who want to start in open source. So feel free, CNCF sponsors that and Linux Foundation. So use that to our advantage. And overall, yeah, check out our website and our Slack and join our effort.
Fantastic. Thank you, Bartek. Any questions? We'll wait just a few seconds here. I think you blew them away, Bartek.
I've got to know how you maintain all of those ASCII diagrams. It's very impressive in all the comments.
I won't maintain. Yeah, there is a cool tool for that. I just used ASCII Flow, I guess, and it's kind of neat. And to be honest, I am not sure how this will age, right? Because we especially around this end-to-end module where we have the unit tests, which are running kind of like any other unit tests, but it's very complex. It starts many, complex sometimes scenario with different deployments. We recently started to add those diagrams for every of those scenario just to show how it works in the code comment. Let's see how it aged. But like, yeah, there are good tools for that.
And then, yeah, so you're talking about like that being a scalability issue for maintenance, right? Because then you have to like keep the mental model, and then if you change the code, you have to refactor the diagram, basically.
Yeah, exactly. So let's see how it aged. I really like the Ascali draw that we used in the first presentation, but the collaboration part is still there. So yeah, I mean, all those things. Let's see how it goes.
Awesome. Well, Jim, I think I'll bring it home real quick, but I just want to thank Leigh. Fantastic presentation. Bartek as well. Really appreciate, Bartek, you coming after your Greece vacation. You'll have to tell us about that next time for sure. And let me share the screen real quick if I can. Can you guys see my screen?
Yes.
Yeah, okay, so this is our next talk here. We have Samia. I think I'm pronouncing her name wrong, but she's going to be coming talking about GitOps. And Leigh, I think you probably know her. She's spoken at KubeCon over in Europe a couple times. And then the following week, we're going to do, I should have had you, Bartek, come to this as well, but we're going to do an observability showcase. And so we have Joe from Grafana, and Jonah's going to be talking about OpenSearch and what's the latest and greatest there. So yeah, if that's it, we'll leave it at that. Thank you, everyone. Thank you, Jim, for hosting our event. And everybody have a great day. We'll share the presentations and the recording probably by tomorrow. So, oh, also, Stacy, thank you so much. You've done a fantastic job above and beyond in promoting the event, and really, really appreciate that. Okay, everyone, thanks. Take care.
Thank you.
All right, bye.
Bye, everyone.